The next video on acids and bases is how to actually calculate the pH and the pOH. To do this, you're going to need these 6 equations. Now, you don't have to memorize them. They're on your reference table. And so the problem is going to be how to know when to use which one. So you simply just have to look at the variables. So there are 4 variables in all 6 of these equations. You have pH as a variable. So this is one of your variables. H plus is a variable. pOH and OH negative are the 4 variables that are in your 6 different equations. So you simply have to look at what's given and what are you trying to get to and figure out the equation that goes with it. Now these first 2 equations, this one and this one, they are the exact same equation, except for this is set up to solve for pH and this one is set up to solve for H+. So you don't even have to do the algebra, it's just a matter of plugging it in. If you're given both the pH and the pOH, you just need to know the sum of them is equal to 14. If you multiply the concentration of H plus and OH negative, you get 1 times 10 to the negative 14th. Now to do this, you also need to know this slide. And we've talked about this a little bit in the previous video, is that when you have an acid, you're always going to have an H in front. When you have an acid, you're always going to have an H in front. If you have a base, you're typically going to have an OH in the back. Now, the other piece that you got to know is that if I give you an acid in the problem, I'm giving you the H+. Okay, so if I tell you the concentration of an acid, I'm actually telling you the concentration of H+. If I tell you the concentration of a base, I'm telling you the concentration of OH negative. So here's an example with that. So it looks very simple and short, but if you don't know what I just talked about, that's where this is going to get complicated. So it's simply asking for what is the pH of 0.05 m of HNO3. So before you can do anything, you have to figure out what this concentration is telling you. So you have to look at this right here and ask yourself, is it an acid or is it a base? And remember, you can tell this simply by looking where the hydrogen is. So it's in the front, so that means it is a acid. Now since this is an acid, this tells you the H+. So again, if I give you the concentration of an acid, I'm actually telling you the H+. If I give you the concentration of a base, I'm giving you OH negative. So you're given H+ and you're trying to find pH. So then it's just a matter of looking at your equations and figuring out which one to use. So is there an equation that has H+ solving for pH? And your answer should be yes. It's this equation right here. So we're simply going to use pH equals the negative log of H+ and simply plug it in. So we get the negative log of 0.05. So the negative log and you should get 1.3. And that's your answer. pH and pOH do not have a variable. So that's a very simple, short, and sweet one. This next problem isn't as easy as the one before. So this time, it's asking what is the molarity of NaOH. So remember, if you look at these equations, NaOH is not directly in the equations, but the first thing you're going to do is figure out, is this an acid or a base? So since it has the OH in the back, that means this is a base. So when I ask for the molarity of a base, that means I'm simply asking for the concentration of OH negative. Okay, so again, if I ask for the molarity of a base, I'm looking for OH negative. If this were an acid, then I'm asking for the concentration of H+. So it tells you the pH of 9.6. So we know the pH is 9.6, and we're trying to get an OH negative. So here's the next problem, is if you look at these equations, there's no equation that directly links pH with OH negative. So this is going to be your go-to equation right here. If you're given pH or pOH and you have to get to the other side, this is going to be the equation to get you there. So in this case, we have pH, we need to get to OH negative, so if we do this, we get to pOH, which will then lead us to what we need to get to. So step 1, when in doubt, if you're given one of these variables, use this equation. So we're going to use pH plus pOH equals 14. So 9.6 plus pOH equals 14. So to get pOH by itself, subtract 9.6 from both sides. Those cancel. So then 14 minus 9.6 gives you 4.4. So we know the pOH is 4.4. So then if you look, there is an equation that has pOH and OH negative. There's actually two of them. You have this equation and you have this one. So then the question is, which one do you use? So remember, this is the same exact equation. It's just set up to solve for different things. So in this one, it's solving for pOH. This one, it's solving for OH negative. So since we're looking for OH negative, we're going to use this equation here. So we're going to use OH negative equals 10 raised to the negative pOH. So now you simply plug it in. 10 raised to the negative 4.4. And you simply plug that in the calculator by doing 10, the little rooftop carrot top thing, raised to 4.4. And you should roughly get 4.0 times 10 to the negative fifth m. Okay, so now this next one is fairly direct. So what is the H plus concentration of a solution if OH negative equals this amount? So if you look, there is an equation that has both of those in there. So we're going to use this equation right here, which just means H plus times OH negative will always equal this. So you're going to use H plus times OH negative will always equal 1 times 10 to the negative 14th. So we're looking for H plus. So we're going to multiply that by 4.5 times 10 to the negative 4th equals 1 times 10 to the negative 14th. So to get H plus by itself, you're going to divide both sides by 4.5 times 10 to the negative 4th. Make sure you remember your parentheses. When you do that, you get H plus equals 2.2 times 10 to the negative 11th. Okay, so it's all about knowing these 6 equations, which are again provided for you on the reference table, but the hard part is knowing which one to use and how to get to where you're trying to find.